Oh, hey, hello, and welcome back. Uh, Same shirt 3 days in a row. Guess what? It's not 3 different days. It's same day, multiple recordings. Anyway, so yeah, the last page of our notes for this foldable on the introduction to probability is talking about complement. And I'm kind of distracted right now because I'm reading the definition it has, and I don't like it. It says the set of all outcomes that are not the event. And that may be true, the set of all outcomes that are not the event, but that is a very specific definition. And complement is a word used throughout math. And what it really means is it completes, if you look at that word, the ment, take that off, put a T at the end, complete. So the complement will complete the entirety of the process. And in fact, I want to write that. It completes the event. For instance, in geometry, if I gave you an angle and I said, this is the angle right here, this blue area, right? But I'm talking about a line, I want to know what its complement is. The complement completes the rest of it. So where the blue might be 30 degrees, the green would then be 150 degrees. Don't put a protractor because those are not appropriate angles. It's more like 45, but that math is difficult. So it completes the event. Now that we've saved all of those extra words, we don't need this space to write all of that jazz, right? But now look, probability of the event plus the probability of the complement. So the complement is going to be everything the event is not. And remember, we've started with 0 and we end at 1. So from 0 to 1 is what our probability is. And you kind of see it up here. So if my probability of something happening, let's look at an example actually right down here. What is the probability of not rolling a 2 on a standard number cube? A couple different ways you can look at it. Roll with me on this one. Let's draw our number cube. And we have the 1, 2, 4. Okay, so how many total sides do we have? Well, we have 6 total sides, okay? And probability of not rolling a 2 on a standard number cube, not rolling a 2. So everything else gets counted, okay? The only way I can roll a 2 is with that one side. So everything else would be a 5 over 6, right? 5 over 6 is going to give me, yeah, let's do this. So I'm going to go on ahead and do my long division, right? 6 on the outside, use the ice cream cone, 5 on the inside. 6 goes into 5, it doesn't, 0 times. Decimal point, my 0. 6 goes into 50. How many times does 6 go into 50? 9 times, right? No, not 9 times. 6 times 8. 6 times 8. 6 times 4 is 24. Times that by 2 would be 48. Yes. See, even Mr. Holloway has to think about the multiplications because I don't always use them. I've become what's called calculator dependent, and that's a bad thing. So now I'm going to subtract 2, use a 0, bring it down. How many times 6 go into 20? Well, that goes in 3 times. 3 times 6, 18. And then that's going to give me a 2. Bring down another 0. Oh, and look, I'm into a repeating set over and over and over. Oops, 3. So 833333. So what is the percentage? It's going to be 83.3%. But I want to talk about this word complement because sometimes we're going to need to know what that is, right? So instead of just counting all of the other sides, if I wanted to look at what is the probability of this landing on a 2, if I landed on a 2, it would be 1 time out of 6, right? So do they complement each other? Well, when I'm adding fractions, let me change that because that's not gonna, I like my colors to stay appropriate. When I'm adding fractions, I need like denominators. Well, 6 and 6 are like. So I'm going to go on ahead and equal sign, and the 6 is going to go on the bottom. And since they are like denominators, I just add the numerator. So 5 plus 1 is 6. No, 6. Now, you know it's a complement because the numerator and the denominator are the same. Okay, and that's more important than these examples here because the examples are kind of silly and I don't exactly like them. The point is to find the complement. So let's change these words up a little bit. There are 13 diamonds in a standard deck of 52 cards. Fair enough. We've talked about decks of cards. If you pick a card at random, what is the probability of not picking a diamond? Well, let's look at this as if we were finding the actual complement. We know there are 52 possibilities in a standard deck of cards, and there's going to be 52 in the possibilities of not finding a diamond, right? So whatever these add up to, it's going to be 52 over 52, right? Wrong color. Well, we know there are 13 diamonds, so I'm going to put my 13 here. Well, now I just need to find out what is the not. Well, how do I find out 13 plus something equals 52? Well, that's just simple subtraction, right? 52 minus 13, beg, borrow, and steal. 12 minus 3 is 9. 4 minus 1 is 3. So there would be a 39 over 52% chance of not getting a diamond. The complement completes the entirety of it. It's going to make sure you have one hole. Let's try this again. A spinner has 5 equal sections, A, B, C, D, and E. Okay, so because we know there is A, B, C, D, and E, we know the bottom number is going to be 5. And since we know we're finding the complement, we can go on ahead and write that we are going to have something over 5 plus something over 5 equals 5 over 5. Now it wants to know what is the probability of not landing on D. Well, to not land on D, or I'm sorry, to land on D, D is 1 out of the 5 possibilities. So we'll put a 1 here. 1 over 5 plus what over 5 equals 5 over 5. So we do our math. 5 subtract 1, and that gives us 4. So the complement in this case would be 4 over 5. Not landing on D would be 4 over 5. Now, if we go back and we look at this mathematically, you've got your little statement right here. The probability of the event plus the probability of the complement equals, well, what does it equal? What's 52 divided by 52? 1, right? What's 5 divided by 5? It's 1. So the probability of the event plus the probability of the complement must always equal 1. If your gonna happens and not gonna happens don't equal 1, then you're living in a alternate universe because that just can't happen. Yeah, so that's complement. And in the future, when you hear the word complement, I hope it helps you remember what happens to the angles as well, because the definition is to complete. Makes life a lot easier once you realize what the root of the word is. Hopefully this helps you. If not, don't forget to like, subscribe, hit the notification bell. Leave me a comment or something too. Let me know what you think and if this helps you or not helps you. If there's another subject you want me to explore, throw it down. If you're a teacher trying to steal me for your classroom, hey, I dig it too. And throw me the teaks that you want to see, and maybe I'll build a video for you on that. Don't know. So I'll see you in class tomorrow.